When a navigator is sailing towards land, let's say Rapa Nui, they start looking for cues like land-based seabirds and the changes in swells as they reflect off of land. And so, but when do they first see land? When does it emerge over the horizon? This, in fact, is a triangle problem. And to figure this out, we're going to use inverse trig. The Earth has a radius of 20,911,171 feet. And Rapa Nui, the highest point in Rapa Nui, is Mount Terevaka, which has a height of just 1,665 feet. And so, how do we do this? How do we solve this? All right, so we have a right triangle. We know the adjacent side, that's the radius of the Earth. The hypotenuse is the radius of the Earth plus the height of the mountain. And so this gives us cosine, since we're dealing with adjacent over hypotenuse. Solving for our angle theta, we get inverse cosine of this ratio, and we get it's about 0.723 degrees. So now that we know that the angle is 0.723 degrees, we can calculate how far it is. What is this distance along the Earth? The ratio of the angle to the full circle, which is 360, over this segment, this arc length, over the circumference of the Earth. So we have this 0.723 over 360 is equal to S over circumference of the Earth. If you recall, circumference is 2 pi times the radius. Here we're using miles. So we end up with the arc length is about 50 miles. That's when they'll first see land.